Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to create the analog output scaling of PLC S7-200 SMART CPU SR30 and connect with the analog module, expansion module, AM03. For expansion this module, there are two channels of analog input here, and there are one channel for analog output. Okay, so here are example of how to wiring the connection from analog output series with the multimeter and connect to the control valve. Yes, so right now I'm connect to the input of control valve, and control valve will feedback the signal to the analog input. Okay, so here is an example and the concept for easy to understand, and I will provide the power 220 volt AC from this plug to the circuit breaker. Okay, and I will use the software SIMATIC MicroWin Smart version 2.5 and connect with the LAN cable from the PC to the PLC. Okay, so this is the concept. So to create the scaling and testing, I would like to let everyone go to create the subroutine and the program. Okay, so let's go. So I will use the existing project that we already learned in the previous video. Yes, so let's open. Okay, in the previous video we already learned about how to create the scale for analog input. Yes, here. And today we will create the analog output scaling. Okay, go to create the scaling. I would like to show the Excel file that I already created the formula, yeah, for create. So here example low scale 0 to 100%, and here is the output that will generate to analog. Yes, and here is the input value. Example, we would like to put the, okay, I will show the value of this one. This is the raw data of the analog output that will generate from the percentage that we set. Example, the control valve set 100%, so the raw value that generate to analog output around 2765. Okay, and if we set point 50%, around 30,824. Okay, follow our formula. Yes, so we need to understand about the formula. So output equal the maximum of the raw value of analog output from 0 to 22,648 multiplied by input minus low scale and divide by output, sorry, high scale minus low scale. Okay, so it will generate this formula. And if we set point 100%, it will maximum. Yes, okay, so the parameter that we will create is 4 parameter. The first one is input, the second one is high scale, the third one is low scale, and the fourth is output. Okay, output. So let's go to create the subroutine. Yes, to create the subroutine, let right click here and then insert the subroutine. Okay, and we will go to property to change the name of subroutine. Example A out, it means that unlock output. Yes, and click OK. So it will change the name to analog output. And let's see here. Here is the subroutine. Yes. Now we just created one more for analog output. Okay. So first we need to create the parameter. The first one is input. So input. It is the real. Yes. So here we can command input value. And the second is high scale, right? The raw data, yes. So the data type is real also, and we can command high scale. Yes. After that, the low scale. So low scale, it is the real also. So we can command low scale. And one more for output, right? So output, it is the integer, right? So integer. So this is the output. Analog output. Okay, so right now we already created the formula. Sorry, created the parameter for input, high scale, low scale, and output. So we must follow our formula. So output equal, yes. So first we need to create the input minus low scale. Okay. So we can command here. Input, or we can copy this formula. Yes, we can command here. So the first one, sub real, right? So sub real, sub between input and low scale, right? So input, low scale, and I will create the temp. Example TE1. Yes, temp 1. It is the real, right? Because output of this one. So the data type is real. So here I can use TE1. Okay. And the next step, we will create the high scale minus low scale, right? So I can use sub real again. So sub between high scale. So high scale minus low scale. Yes. And here I create the TE2. And the data type is real also. Yes. So this one TE2. Yes. And don't forget put the always on. Yes. So SM0.0 for always on. Otherwise it will error when we compile. Okay. So we will take this one, the maximum value of analog output, multiplied by this box. Okay, so I can use real. Yes, multiply real. Yes, so multiply between input. So maximum to 27,648.0. Yes, because it is the real. Multiplied by input minus low scale, right? So this one, and we'll generate one more for TE3, and the data type is real also. Yes, so TE3, and we need to divide, right? Sorry, this one divide first. Divide between this one and this one. So I will insert here one more box. So divide real here. Divide between this one and this one. Then I will create one more for TEM3, right? So TE3. Then I will copy TE3 to here, and then we'll generate the TE4. It is the real also. Yes. So TE4. Okay. So let me explain again. So here we need to divide between input minus low scale and high scale minus low scale, then multiply by the maximum of raw value of analog input. Okay, so this one divide this one, and then this is the result, and we will take the result of the divide real to multiply by maximum of raw value, and then we will got the TE4. Okay, and for this one is the real, right? But the output is integer. Okay, so we need to convert from the real to integer, right? So I will use the function truncate. Yes, this one. So first convert this one to the double integer, right? So I will create TE5. It is the double integer, DINT. Yes, this one. So this one TE5, right? Okay, and then I will convert from double integer to integer. So double integer to integer, right? So di to I. Okay, and then I will use TE5, and this is the output, right? So output. Yes, and then I will compile. Yeah, click here. So error 0. Yes. Okay, so we can use this subordinate by go to call. Yes. So I will copy this one to here, and then drag and drop the analog output scaling to here. Yes. So we will got like this. So for output we can use AQW 16, right? Let's go to check on the hardware configuration. Yeah, here. So the analog output will start from AQW 16. Yes, and it is the 0 to 20 milliamp. Okay. And for the scaling, we can start from high scale 100% example, and low scale 0 to 0.0. And here is the input value. Example MD4. Yes. So we can compile. Yes. Okay. No error occur here. And then we can download to the PLC. But before download to the PLC, let's connect the LAN cable to the PC and to the port of PLC. Okay. And then make sure the computer is set the manual IP address 192.168.2. something. Yes, here is example. I set 192.168.2.253, and for subnet mask we can use the follow this one. Okay, and we can check the connection to the PLC. Example ping 192.168.2.2. Yeah, because the IP address of PLC is 192.168.2.2. Okay, so it's so like this. It means that we can communication between our PC to the PLC. Okay, so we can download by click this button, or we click the communication, yeah, here, and then find the CPU. Okay, right now it found one CPU that has IP address 192.168.2.2, and here is the MAC address of this module. And click OK, and then click the button download. Yes. So if we download, it will stop the CPU. Yes. So let me show. Okay, right now the CPU is running. So if I click download, yes, click yes to stop the CPU. Yes. So right now the CPU is stopped, and then click yes again to run the CPU. Yes, because we already downloading. Okay. So we can online. Yes. So right now MD4 input is 100%. So the milliamp show 20 milliamp right now. Okay, it show 20 milliamp. So if I adjust to 50% example, it will show around 10 milliamp. Yes, because the range is 0 to 20 milliamp. Okay, if I put 0, it will show 0 milliamp. Okay. So we will create the HMI for simulation. Yes. So let's go to the existing project. Yes. So actually we can set point from the HMI. Yeah. Example, set to open the actuator or control valve from 0 to 100%. So we can do also. Yes. So let me open the existing project. Okay, this is an existing project. So we can adjust something here. Okay, it is the tank. So it is analog input. Yes. So I will create one more text for set point and feedback of the control valve, right? Because we connect to the control valve here. Yes. So we need to actually we can use 0 to 20 milliamp, or we can scaling a little bit for 4 to 20 milliamp. Okay. So I need to create the take two for MD4. Yes, this one for set point, or we can write set point. So set point to control the control valve. Okay. And one more for feedback. Feedback from control valve. So example MDH. Okay. And then I will copy this one. Yes. So this one should be text file. So control valve. Setting. Control valve setting, and then go to property, and then change this one to text. I will increase a little bit for size 16, and then choose this one to center and middle. Yes, and then go to the color. Maybe I use the yellow color. Yes. Decrease a little bit to 14. Yes. So this one is SV, right? Set point value. I will use the white color and increase a little bit for size. Yes, like this. And this is the feedback. Yes, feedback from the control valve. So this one is process variable, right? So PV. Okay, and the unit is percent, right? Okay, and this 1% also. Okay, and for this one SV, right? So we need to use the input because we need to tie the sum value to control valve and choose the take set point. Yes, and here is the feedback, right? So I will revise the program. Example, I will use the one more input for feedback, right? So I will use the scale. Yes. So this one should be AIW 18, right? Input 1 and scale from 0 to 100%. So 100% for high scale, 0% for low scale, and this is a MDH. Yes, because we already created here. Yes, feedback. So this one should be output and then choose the feedback. Yes. Okay, right. And then save the project, and then we can download this logic to the PLC again. Yes. CPU will stop and start again, and then online. Okay. So right now I will revise the connection from standard soft from channel number 1 to channel number 2 of analog input. Okay. So if we simulation, okay, simulation. Oh, this one not C, right? So I will adjust this one a little bit more. For existing data, right? Of level. Okay, like this. Okay, and then save again, and then simulation again. Okay, so right now if I set point to 50%, yes. Okay, let's see the milliamp show around 9.99, around 10 milliamp. Yes. Okay, and if I adjust the input, yes, let's see here the feedback is show around 48, 50, yes. And if I set point to example 75%, yes. Okay, let's see the milliamp around 15, yes. And this is the feedback from the control valve, yes. Actually we can adjust, yeah. But for the real practice, we take the signal from the output of the control valve, right? Okay. So if I adjust to 100% or 90%, yes. Let's see, the milliamp is show also, yes. And this is a feedback from the control valve, yes. So it will increase also. Okay. And if I adjust to 100%, yes, it will show around 20 milliamp, yes. And then the feedback will go to 100% also, yes, from the control valve. Okay. So this is just example for how to create the analog output scaling to control the electrical devices or some device that can use from 0 to 20 milliamp or 4 to 20 milliamp. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.